This is the star HD 139139. In terms of its class, it is a yellow dwarf, just like our Sun, so it is not surprising that they look alike. The Kepler telescope recently discovered it and sent the information to study. Analyzing the data, astrophysicists were extremely puzzled. In this star system, Kepler detected signals that resemble the tracks of as many as 28 exoplanets. Still, don't be surprised. It is not yet a sign that there are any exoplanets at all. Let's try to figure out what Kepler actually found. We'll start with a rather strange question: how many exoplanets can there be in the single star system? I'll tell you a little secret. There's no definite answer because no one knows for sure. Theoretically, there is no limit, because there is no law that says that. For example, a star can have a maximum of 20 exoplanets and that's it. Probably, the number of planets around the star depends on how much material is available for their formation, and how compact the system itself will be, so that it is also gravitationally stable. If a star does form many planets, they are likely to be predominantly small. Giant planets take up a lot of material, and they can prevent additional planets from forming in the rest of the system. So far, our solar and Kepler 90 are the two systems that have been found to have the most planets, 8 each. It is probably possible to find a star with dozens of planets in a stable configuration. It remains for mankind to find out how probable such systems are. Now, let's go back to the star HD 139139. It is located in the constellation Libra and is 350 light-years away from Earth. The star is slightly larger and brighter, but identical in temperature and much younger than our Sun. It is only 1.5 billion years old. By the way, HD 139139 has a companion star, a red dwarf. So, the Kepler Space Observatory discovered this yellow dwarf and recorded 28 strange transits that would normally indicate that there are planets orbiting the star. But perhaps we're talking about something like a whole new type of sunspot. We will talk about that later. Let's explain what transit is. The transit method of detection is the most popular one. How does it work? The principle is simple. When an exoplanet passes between its star and an Earth observer, the brightness of its luminous disk is reduced by a clearly detectable value. Thanks to this, it is possible to estimate the size of that exoplanet. Using this method, the Kepler Space Telescope managed to detect thousands of exoplanets before it finally shut down in November 2018. However, the observational data is still being received and continues to be studied on Earth. Such is the case with the star HD 139139. Kepler observed the star for 87 days, and during this time it recorded 28 transit signals, which indicated that exactly exoplanets orbit around HD 139139. The shape of the diagrams of changes in the luminosity of the star during the transit of exoplanets on its disk differs from the shape of the graph for transits of dust clusters and other objects. Only 2 of them were commensurate with giants like Jupiter. The size of the other potential candidates was small but slightly larger than the Earth, and they all resemble each other. That is, 26 exoplanets commensurate with Earth. The discovery is amazing and very rare. But, the chances that these are really planets are very small. The fact is that in such a short time, 28 planets can pass between their star and Earth only if they are all orbiting very close to the star. Planets as distant from their star as those in the solar system are unrealistic to pass between their star and a distant observer in such a short time. The farther a planet is from its star, the longer the period of its orbit around it. Therefore, an observer from another system can see the transit of all planets, for example, in the solar system, between the Sun and a distant observer, only after many years of waiting, but not after 87 days. However, if the planets of the system HD 139139 really rotated close to their star, their transits would have had time to repeat in 87 days, but this didn't happen. The duration of the transits of each object was different, It ranged from 45 minutes to 7.5 hours. So the scientists realized that we are talking about different signals. But if these are not exoplanets, then what is this strange phenomenon? There are several assumptions, or it's better to say hypotheses. As we have already said, HD 139139 has a companion star. Astronomers have suggested a model in which the planets in this system are common, that is, they orbit both HD 139139 and the other star. This could explain why the transits were not repeated. If the planets have to make a wide circle around the two stars, the transits don't have to repeat quickly. Nevertheless, this option looks rather dubious. It doesn't explain how the 28 planets were able to pass between one of the stars of the system and an Earth observer in just 87 days. Another hypothesis explained the mystery with the help of numerous asteroid clusters, which could mimic planetary transits in case of sufficient size. However, scientists were forced to reject this option as well. Such asteroids had to be unrealistically dense. In addition, there had to be too many of them. As a rule, if none of the scientific explanations can be applied, then science fiction comes into play. So it happened in this case. There is an assumption that non-periodic transits can be connected with the activity of hypothetical extraterrestrial civilizations, which can build something like the Dyson sphere. Dyson sphere is a megastructure. Imagine that some advanced civilization managed to build a shell around such a huge object as a star, and this structure absorbs all its energy. Hypothetically, it is possible. However, if HD 139139 has such a structure, then the civilization that built it is unlikely to come from this very system. Remember, the age of the star is 1.5 billion years. When our Sun was that old, the Earth was still inhabited by single-celled life, and it is very doubtful that life developed much faster near another yellow dwarf. Previously, astronomers have already found stars whose luminosity varied strangely due to the transit method. For example, it was characteristic of the so-called Tabby star. To explain its anomalous non-periodic transits, astronomers have also hypothesized about the megastructures of another intelligent species. However, long-term observations of the Tabby star have shown that its luminosity varies greatly in the visible and ultraviolet spectrum range and is much weaker in the infrared range. It seems as though the star is surrounded by dust clouds. The dust well absorbs shorter wavelengths of visible light, but poorly absorbs the longer infrared wavelengths. Therefore, the hypothesis about the artificial nature of the fluctuations of the luminosity of the Tabby star is not so popular today. Regarding the star HD 139139, the researchers focus on another explanation. They consider unusual spots on the disk of this star, which have a size close to planets, as the most probable scenario of these non-standard transits. This option also has drawbacks, because the spots on stars like the Sun exist for a relatively long time and must reappear in the telescope's field of view during the rotation of the star around its axis. However, the actual transit signals from HD 139139 are non-periodic. In other words, if these are indeed spots on the star, they should have a lifetime of only a few hours and disappear before the star makes a complete rotation around its axis. Examples of such short-lived spots on stars of this class are not yet known, neither from observations of the Sun nor from studies of other yellow dwarfs. If the explanation of the oddities of the star HD 139139 really comes down to spots, we are talking about the discovery of a completely new type of spots. During its mission, the Kepler telescope observed 500,000 stars, but it had never seen one like this. Scientists still don't know what to do with it. They suggest pointing the test telescope to HD 139139 for further observations. It's even planned to expand the mission for this purpose. In any case, the answer, I believe, will be found, and it will be very simple, as usual.